After this short intro, we'll clarify a bit with a very simple and visual example. Similar to our SAT GPA regression from the last section, we will explore an SAT admissions problem. In this case, we are not interested in the GPA a student will obtain at graduation, as they won't even have a GPA if they don't get admitted. Instead, our focus will be predicting whether a student will be admitted or not. Alright, let's switch to Jupyter so we can explore the dataset. I'll import NumPy, Pandas, Stats Models, Matplotlib.pyplot, and Seaborn. Same packages as before. What I am going to do is call the sns.set method to override the default matplotlib settings with the beautiful Seaborn ones. Okay, let's get to work. Let's load the information from the CSV into a variable called raw data. Cool. As we can see, raw data is a data frame with two columns, SAT and admitted. Each row represents a different student. I believe the two variables are self-explanatory. Like dummies, we must convert the yes and no entries to ones and ohs to be able to use the data for quantitative analyses. I'll quickly create a new data frame called data, where all no entries from raw data will be mapped to 0, while yes entries to 1. We've already done that, so nothing new so far. Great. That's our final data frame. Now, let's visualize the data we have. We are predicting admission, so the admitted column will be our y variable, while the SAT score will be our x variable. Okay, knowing this, let's create a scatter plot in the familiar way. This is a pretty strange scatter plot, isn't it? Well, that's what happens when we deal with categorical outcomes. Still, if we focus on this scatter plot, we will notice that for all the observations below, the outcome was 0, or they didn't get admitted. Conversely, for all the students above, the process was successful, and they got admitted. Easy. Now, let's see if a linear regression will be a good fit. I've prepared a linear regression on the data using the same methodology as in the last section. I'll skip its summary and use the respective coefficients to plot a regression line. During the rest of this lecture, please don't focus on the code, but rather on the insights that the plots give us. Okay, let's execute the code. Not only is this linear regression an awful fit, but it also predicts values which fall outside the natural domain of admission. This regression doesn't even know that our values are bounded between 0 and 1. Pretty dumb, right? Well, not really. Linear regression is a great predictive technique, but is simply not fit for this kind of analysis. The first assumption of the OLS was linearity, and it is violated. Our data is nonlinear. Thus, we must use nonlinear approaches. So, what does an appropriate regression line look like? Well, something like this. It is bounded by the two outcomes, 0 and 1. What about its interpretation? This function shows the probability of admission given an SAT score. I'll quickly interpret it for you. When the SAT score is relatively low, the probability of getting admitted is 0. When the SAT score is relatively high, the probability of getting admitted is 1, or 100%. A score in between 1600 and 1750 is uncertain, so there is a probability associated with it. For instance, if you score 1650, you have roughly 50% chance of getting in. With 1700, though, you have 0.8 or 80% probability of a successful application. That's more or less how this curve works. We would call this curve a logistic regression curve, while the method of prediction, logistic regression. Welcome to binary prediction. In the next couple of lessons, we will explore the topic thoroughly. See you there!